Welcome to section 4.6, Inverse Trigonometric Relation Graphs. At the end of this section, you should be able to answer these questions. How can we plot an inverse trigonometric relation graph using parametric relations? How do we choose principal branches for inverse trigonometric functions? What are the domains and ranges for the inverse trigonometric functions? How do we calculate exact values of inverse circular functions? What is the property that discusses the composite of a function and its inverse function? What restrictions are placed on this property? Let's start by looking at the graphs of the inverse trigonometric relations. I'm going to pull out my trusty calculator and check that I am in function mode and radian mode. I'm going to start by graphing the function tangent of x. And I'm going to do a zoom 7 trig so that the window is appropriate for a trigonometric function. And we can see the repeating pattern of the tangent function, which repeats every 180 degrees or pi radians. Now, let's think about what the inverse function or inverse relation should look like. Remember that inverse relations are reflections of the original functions over the line y equals x. Let's see if we can picture that. Now let's go in and actually plot the inverse tangent, second tan of x. So when we graph this, we should see these repeating images reflected over the line y equals x. We only get one of the images, not all of the repetitions when we plot the inverse tangent. Why is that? Well, part of the reason is that we are in function mode, which means that the graphs that we plot must be functions. So we only see one of the branches which passes the vertical line test. If we saw multiple branches, we would no longer pass the vertical line test. But if I truly want to plot the inverse relation, I want to see all those additional branches. How can I do that? Well, if we remember earlier in the year, we learned that we could plot the inverse relation graph of a function by using parametric equations. So that's what I'm going to do. I'm going to change my mode to parametric. Now, I'm going to go to my window and make sure that my t values match my x values so that I fill the entire window. Here, we're going from negative 2 pi to 2 pi for both t values and x values, so we should be fine. Now, in my y equals screen, if I wanted to plot the tangent function, I would use t for x and tangent t for y. And if we graph that, we see basically the same image with these asymptotes drawn in that we saw in function mode, a repeating pattern every pi radians. To plot the inverse relationship, I switch the information in my x and y equations, just like we switch x and y to determine an inverse. So I'll start with tangent of t in the x line, and then I will put t in the y equation. Now when we graph, we see the repeating pattern, just like we wanted. So since all of these graphs are part of the inverse relationship, And when we're in function mode, we only see one of those repeating images. We'd like to come up with some logic as to which of these repeating branches we're going to see when we plot the inverse in function mode. Now let's look at how the calculator determines an answer when we input an x value into an inverse trigonometric relation. If we look at the graph of the arctangent, we can see that if we ask for the y value when x equals, for instance, 1, we get multiple possibilities as an answer. But if I actually ask for the inverse tangent on the calculator of 1, I only get one answer. What the calculator does is it chooses a value off of what we call the principal branch, because with that one value, we can then determine the other y values based on the pattern of the individual trigonometric relation. The principal branch for each function is determined according to a certain set of criteria. These criteria are listed in priority level, the first being that this principal branch must be a function. The second criteria, it must include the entire domain of the inverse trigonometric relation. The third criteria, it should be one continuous graph if possible. The first two criteria are absolute musts. These next three are a decreasing level of priority. The fourth criteria, it should be centrally located near the origin. And the fifth, if there is a choice between two possible branches, use the positive side. Let's take a look at how this would work for each of the 6 inverse trigonometric relations.